Now we're going to graph by hand this function f of t, which is equal to arctangent of 1 over t. So the first thing that we have to do is we define the domain of definition. So we know that the arctangent is defined for r. Here we have the restriction coming from 1 over t. 1 over t is defined when t is different from 0. Therefore, we have the domain is r star. That means r minus or private, or we take the 0 outside of r. Okay. And next, what we do is we find the limits. Okay. So the limit of f of t as t goes to plus infinity. Before doing so, we note that f of minus t is minus f of t. Okay, that means that our function is odd. Therefore, we work only on 0 excluded plus infinity. So we're going to work on this one, and we're going to take the symmetric with respect to 0, the origin. Okay, or we can work out everything. But just to notice that being an odd function can reduce the work by half. Here, since the arctangent is continuous, okay, we can take the limit inside. We can do something like this. Arctangent, the limit of 1 over t as t goes to infinity. And here, when t goes to infinity, this is 0. Okay, and the arctangent of 0 is just 0. Therefore, our limit as t goes to infinity, f will reach 0. We'll get closer to 0. Okay, and next we're gonna have the limit of f of t as t goes to 0 from the right. The same thing here, we can get the limit inside, the limit of arctangent of 1 over t as t goes to 0 from the right. We can get the limit inside. The function arctangent is continuous. So here we have this limit, 1 over t as t goes to 0 from the right. And we know this is plus infinity. And the arctangent, when it gets bigger, it reaches pi over 2. Okay. Now we need to notice one thing, that we know this. You need to know this. Arctangent is bigger than 0 for all t's bigger than 0. And therefore, arctangent of 1 over t is bigger than 0 for t bigger than 0. That means t is in this interval. That means our function is on top of the x-axis when we are in between 0, not included, and infinity. Okay. Next thing is that we're gonna find f prime. The derivative f prime is here. We're gonna use the change, the chain rule, and we're gonna have minus 1 over 1 plus t squared, which is less than 0. That means our function is decreasing. So this is negative all the time on t belonging to 0 plus infinity. That means our function is going to be decreasing. Notice that it's a positive decreasing, having limit pi over 2 on 0 from the right and limit 0 when t gets bigger. Okay, now we're going to see if we have any points of inflection. So here, if we do the second derivative, we have 2t minus, it's 2t over 1 plus t squared. Okay, and this is, so here the only point where f second is 0 is when t is 0. And we have the function is not defined on 0. Okay, and this second derivative is bigger than 0 when t is bigger than 0. That means it's concave up. Okay, so we get all the information to draw our function. Okay, we said that it's positive. That means that we're gonna be here on the, so this is, let's write x and y. So here that means it's not defined here. When x is 0, that means this is a vertical asymptote. When we get closer to 0 from the right, we reach pi over 2. So I'm going to use approximate value. This is, let's say this is pi over 2, and it's symmetric, it's minus pi over 2. Here, it's decreasing and positive. It reaches 0, get closer to 0, when I get to plus infinity, and it's decreasing with no points of inflection. That means it's like this. Okay, the next thing that I'm gonna do is I'll take the symmetric with respect to the origin, because it's an odd function, and therefore I have my function is like this. I think this is the symmetric. I'm not doing it right, but it's, you see, you get the idea. You take the symmetric with respect to the origin here, any point. Okay, you take the symmetric and you get the graph. And is there anything that I missed? I think that's all. So this is how we do the graphing. We didn't use tables because this is this is very quick and it's easy to draw. The only exceptions is these limits here. You need to know these limits, and you need to remember how when the arctangent is positive or negative, and also the limits on the right and on the left for the 1 over t. And also this question of continuity of two functions. Okay, the limit exists and one function is continuous. This is very crucial in dealing with these composite functions. And besides that, I think that's all we need. Okay, thank you very much.